Hey folks, this is Mr. Schmidt. I'm just having a quick little update of our storm time lesson. Um, Nothing new was introduced, but I just gave a practice session, so I thought I'd go over some of the answers here. Okay, so what we're looking at is the graphing motion and then the review. A number of people have been turning in labs and they've been like taking pictures with their phone of the screen. Please just take a screenshot with your Chromebook and insert it into your Google Doc. It's just so much easier to read and so much more professional looking. Okay, next up, normally we do a lab with matching motion, but we could not obviously be in person in lab, and I couldn't send out all the lab supplies and all the computers to everybody to get this all done and then get it all back. So the best approximation I could do to matching motion is this PhET experience. So the idea is you are this walking man here, and as you move, the chart at the bottom moves. And then as the person moves back, everything moves differently, okay? And then you can change how fast they're accelerating or what direction they're moving, okay? And hopefully that gives you another way of approaching these graphs that you can look at as Running Man was moving to the right, but went more positive. Okay, then Running Man turned to the left and started to return back to zero. Okay, and you can see their corresponding velocities and accelerations. So if this was a proper lab, I would give you target shapes to try to make on each of these, which is quite tricky, and I find nearly impossible on the chart. It's tricky to do in person, in fact. So I thought we would just look at this, try to play with it a little bit, get yourself ready, because of course what we're trying to prepare for is we are going to have our first quiz, which I'm going to turn on here in a little bit. But maybe you wanted to see the video before that quiz started. All right, so these are the types of things you should have with you. So remember, with the quiz, you could have a piece of paper, you could have your calculator, okay? Please don't use other websites though, or anything, other internet connected portions or other people, okay? And then to get you ready for that, I asked you a series of questions that you could practice if you wanted to, okay? Key thing about this one is rolling down the ramp, you could take a lot of measurements. I threw this one in here, does not matter, okay? You just need to know initial and final anytime you're doing any of these equations, okay? None of these equations ask for a midpoint. Even when they're asking for average, that doesn't mean they're asking for some middle part. Okay, so we just need the initial and we need the final to do these, okay? The units for acceleration, by the way, are meters per second or meters per second squared, okay? And if we look at this average speed of the ball over 3 seconds, all right, I'm going to jump down. We have all the answers down here, okay? And remember, just like all the time, hopefully you're already here since you found the video. All right, so you'll have already found a video here, but you can also find the answer key. But maybe you're confused on how I'm doing one of these. All right, so average velocity is change in total distance over change in total time. So that's a change, a total of 2 meters over 3 seconds. So it's 2/3 meters per second. Okay. Now, if we want to go from average to final, we have to double our average. Okay, we'd also have to involve the initial, but since it was dropped, that number is 0. Okay, and that gives us 1.33. Okay, our acceleration one, we're actually kind of using a modified version of this third equation, all right, which is more like aligned with the fundamental definition of acceleration, the change in velocity over the change in time. So if it ended with 1.33 and it started at 0, it had a change of 1.33. Once again, it went from 0 to 3 seconds. So now we went from 4/3 to 4/9. So we should get a number close to that. Okay, and going back to the question again, all right, the next question was, I'm jumping around here. Number 3A, sorry. What equation would you use to calculate the velocity if you know the acceleration, all right, and distance, but you do not have the time. So we need an equation that does not have time in it. So we come back here, cross out anything that has time in it, and we want an equation, okay, that has acceleration and velocity, right? So all the ones we did not cross out, we need something with acceleration and velocity, okay? And that leaves us with our second equation, okay? So we come down to our answer, we see what was the second equation in that scenario. All right, and then finally, dropping the ball. You drop a ball, it bounces twice, okay? Some people ask me what numbers you should use. At this point, we're just looking for shapes. So you want to go up, you know, you could try to do like if you had 80% return or 50% return, you try to match that. That's not going to be what's graded this week. What I'm looking at is the shape. So what we see here is this entire time the ball is going down. So it has to be the negative sector. And it started at 0 and ended up going down super fast. So it starts at 0 and ends up going down super fast. Then it hits the floor. So there's a great big impact and a great big spike as the ball shoots up. Now it is an upward slope that entire time. So after it left the ground, it continues to travel upwards in the positive direction, okay, until it reaches the peak. When it reaches the peak, then it's going to start into the negative and keep coming down. Okay, and that is the two bounces. Now, when you get to the bottom, the entire time it's in the air, any object in the air on Earth should be pretty close to negative 9.8 meters per second squared as your acceleration. Okay, once it hits the ground, we're going to have some unknown acceleration that's going to be super big. Okay, once again, we don't have the numbers, we don't know, but there's going to be some big acceleration right at that impact point. When the ball leaves the ground again, it's all 9.8 all over again. Okay, this would not be a perfect chop. There would be like a slight, you know, super elongated parabolic arc as the ball compresses and expands. But once again, I don't want to get too far into like the spring energies to follow all those. All right, so that takes us through all the questions and all the answers. So the lab I'm about to post, 8 questions, lots of multiple choice and matching. A couple of them are this type of thing of fill in a number, okay? And then some of the matching are, or multiple choice are which graph or which shape of the graph is the most correct. Okay, so with that, hopefully you folks are all ready for our quiz. Remember, when you start a quiz, you have 1 hour to complete it, and then it clocks out. Best of luck, and remember, even if you get things wrong, you'll have a chance on later exams to correct that score.